On our previous video, we were able to establish already that this given equation is an exact differential equation. Now, our goal is to solve for this equation. Of course, a short review because you also need this right now. This could be expressed in this form, m of xy dx plus n of xy dy equal to 0. Hence, our m of xy is the function paired with dx. That's 2x minus 1. We can see it here. And our n of xy is the function paired or multiplied to dy, and that's our function here, 3y plus 7. Okay? So again, this is already an exact differential equation. Our goal now is to solve for this equation into this form, f of xy is equal to a certain constant c. We need to reach this type of form. So let's start by looking into what is f of xy. If we have already established that our equation is an exact differential equation, it's actually the result of the integral of m of xy dx plus a certain g of y. These are a function of y which we'll be using later. So simply plug in here m of xy. So you have 2x minus 1 dx, right? Plus g of y. So simply integrate this side here. So you have the integral of 2x dx minus the integral of 1 dx plus, of course, g of y here. Of course, you can take 2 out if you would like to, just the simple processes like that, or you can simply use, let me just simply take this out here so I will be saving some spaces. And of course, 2 will be out here. Take note, that's actually the property or part of our what we have learned before for integrals. If you have a constant here, you can always take that out. Okay, that's why you will have 2 outside. That would mean you have 2. This is x squared minus 2. Let's just simply leave c later, or at the meantime. You have here minus x because that's what is the integral here, and you will have plus g of y. That's y, g of y. Therefore, f of xy is just equal to x squared minus x plus your g of y. This is already the solution, but we still need to look for what is g of y. That's the next thing we need to look at. What is g of y? Because if we are done solving for g of y, we are now done solving for f of x of y, then we can just simply equate it to z and then we're done. So how do we solve g of y? This is the next process here. To solve for g of y, we are going to take the partial derivative of f with respect to y. That would mean the partial or derivative of this entire function, f of x, y, you will have x squared minus x plus g of y with respect to your, let's just simply write it like this, with respect to your independent variable y. If we are going to take independent variable being y, that would mean this can be considered as a constant because it doesn't have y. This is also considered to be a constant. Okay? In short, when we take the derivative of a constant, what happens then is it's just 0. Because we are taking x squared as a constant now. Minus x, which is also 0. And you will have here g prime of y because this is the function with y variables and we are going to take its derivative. In short, the first order derivative of f, a partial derivative of f rather, with respect to your independent variable y is g prime of y alone. So how do we solve g of y if we have g prime of y? We need to reach this process saying that the first partial derivative of f with respect to y is just equal to your n of xy. This is one of the equivalents you need to remember if you're solving exact equations. And what is n of xy? So 3y plus 7 is your n. And simply equate it like this. So this is g prime of y is your n of xy, which is 3y plus 7. Since we're solving g of y, not g prime of y, so you take the integral of that, dy, and you have here the integral of 3y plus 7 dy as well, to get g of y, to which you'll be pairing or placing here. Okay, so let's continue. So once you integrate that, that's simply g of y equal to, of course, you can have it like this, 3y dy plus integral of 7 dy. You can always take out the constant. You will have y dy plus 7 of dy, right? You have those integrals. You have 3 y squared over 2, okay? That's what happens here, plus 7y. Or your g of y can be written as 3 halves of y squared plus 7y. This is just your g of y, part of your solution here. So please copy that. F of xy is x squared minus x. So you have f of xy is equal to x squared minus x plus g of y. G of y is this, so substitute that, x squared minus x plus 3 halves of y squared plus 7y. And since f of xy is equal to c, this is the solution, simply equate that, this entire to c, and then your final solution here is x squared minus x plus 3 halves of y squared plus 7y equal to c. This is now your solution for the exact given equation. So what are the things we used here? We went back to this function to identify m and n. You have this as part of your solution, so you're taking this form here. G of y popped out. Take the first partial derivative of your function f with respect to y to get g prime of y. And since since this is just equal to your n identified earlier, equate them. Solve for your g of y by integrating both sides. The solution will be paired to your original f of xy solved earlier and equate them to c. That's your final answer. Thank you very much for watching.